Oompa, Loompa, Doompa-dee-doo. I've got another puzzle for you. Oompa, Loompa, Doompa-dee-dee. If you are wise to...
Alright everybody, welcome to the video on Chapter 5, Section 4 for solving compound inequalities. Okay, so we need to know what compound inequalities are, and then we're going to solve them. They're going to contain words, you can see right here, contain words like and we're going to be able to graph that, and we're also going to see the difference between and or, and how we graph those. Okay. So first let's look at inequalities containing the word and. When considered together, two inequalities such as h is greater than or equal to 52 or less than or equal to 72, they form a compound inequality. An inequality containing the word and is true if both inequalities are true. So when we get this right here, x is greater than or equal to 3 and x is less than 7, we have x is greater than or equal to 3 looks like this graph right here. Okay, and then x is less than 7 looks like this graph right here. When we say and, we're basically combining those graphs, and it's where they overlap. Okay, so when you see and, we should think they overlap, and the answer is going to be in the middle. Okay, so when we see and, they overlap, and the answer is going to be somewhere in the middle. So it's really just that simple. So if we were to solve this, what we can do is we can write this as two different inequalities. So we could write it out as -2 is less than or equal to x minus 3, and x minus 3 is less than 4. So we get these two different inequalities. We graph them both. So we graph the first one, and we graph the second one, and then the answer is just the overlap. It's really just that simple. Separating them can, I guess, be the hard part. I'll even show you in class how we can not separate them and solve. But that's a little bit more complicated, so I'm going to save that for class. For right now, let's look at, we'll do 1A together. Actually, 1A is set up nice and neat for you. So you try 1A. We'll do 1B together right now, and then you can pause the video and try 1A. So 1B, if I were to separate that out, I would have 6 is less than or equal to r plus 7. And r plus 7 is less than or equal to, sorry, not less than or equal to, r plus 7 is less than 10. So we solve this, and we get r is greater than or equal to -1. And we solve this, and we get r is less than 3. So on a number line, and this can just be a sketch, you can see mine is not that great. If we had -1, 0, 1, 2, and 3, what this looks like is r is greater than or equal to -1 is a solid filled in circle, and it's going to go forever in this direction. But because I know it's a compound inequality, I'm not going to fill it in right now, because I know I also have r is less than 3. So r is less than everything for 3, and it's greater than -1, so it's just those two circles to one another. That's it. You go ahead and try 1A. Pause the video right here, try 1A, and we'll see what you get. Go ahead and pause the video now. And hopefully your answer looks something like mine, where you have -8 and -5 as the two numbers, and then it's everything in between them. Okay. Let's take a look at inequalities containing the word or. Okay. Another type of compound inequality contains the word or, and what that means is it's true if either one of the items is true. The difference in the picture here is that the inequalities go in opposite directions. Okay, they go in opposite directions. So here we have x is greater than 2. That's everything going this way. Right here, x is less than -1. It's everything going this way. So the answer is just those two inequalities on the same number line. That's it. When problems use inequalities, within is meant to be inclusive, so use greater than or equal to, less than or equal to. That's just vocab there. If we see the word within, it means we have the equal to underneath the inequality. If it uses the word between, you'll notice no equal to. So that's just deciphering word problems. That'll help us on real-world problems like this. So the human ear can only detect sounds between the frequencies of 20 and 20,000 hertz. So the frequency has to be less than, right here, it has to be less than or equal to 20 or greater than or equal to 20,000. Okay? So the problem, we can hear things in between those two. Okay? Now, the phrase, again right here, the phrase at most in example 2 indicates less than or equal to. Okay? and they say in the question, you know, between the two, the phrase at most is less than or equal to. It could also have been phrased as no more than, okay? So here's what we have. We have a graph that, right here, we have the solution set of, you know, that's right about 20, and it's less than, and this is 20,000 or more, and that's greater than. And the union right here is what those two together. It says, notice that the graphs do not intersect. Humans cannot hear sounds at a frequency less than 20, okay, and greater than 20,000. The compound inequality is written as this, and it's really that easy. The kicker here is that we got to make sure we read the directions. The question says, write an inequality that they can't hear. So this is what humans can't hear. The question says what they can, but then tells you to graph what they can't. Just sort of a check to make sure you're reading things kind of question. Take a look at number 2 here. The company is manufacturing action figures that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality. So if we were to write this, we could say, you know, action figure, we could use 11.A. So, A. So A has to be greater than 11.2, and A has to be less than 11.4. And then if we were to graph that, that's pretty simple. We have this right here. We have 11.2, 11.3, and 11.4. And that one is an and, okay? So it's right in between them. Okay, and that is it. All right, easy peasy. If we were to solve and graph a union like this, again, we separate them, solve, graph each one, and then we get what we get. Now on this one, you'll notice that we had m is greater than or equal to -3, and we have m is greater than 5. Well, the union of those two is both of those. Because this first one sort of overlaps the second one, this is just the answer, okay? Because it overlaps them. It says, notice that the graph of m is greater than -3 contains every point in the graph of m is greater than 5. So the union is just the graph of the first one, and we could write it out just as that also as the answer. So the solution set here. Let's go ahead and take a second, try and graph both of those, see what you get, solve them first, and then graph those. Go ahead and pause the video, get answers for 3A and 3B. Go ahead and pause here. Okay, hopefully you've unpaused now and you can see that on the first one we had two distinct different ones, one going that way and one going this way. On the second one, on 3B, we had x is less than or equal to 9. We also had x is less than 8, but that is incorporated into x is less than or equal to 9, so it's everything there. Okay, if you have questions on those, remember to write them down. We'll go over them in class. If you do me a favor, try these 5 problems. Make sure you got the hang of this. It's a short and sweet video, so hopefully you take the time to try these 5. It'll be important when we get in class that we know the difference between and or, and then there's a good word problem here for us to practice that skill. That's it for the notes, guys. Nice, easy transition back into, you know, school and learning and such. Good luck. There's one more video on 5-5 I'll need you to watch. That'll be posted later, or right now. You won't know later from right now because you're not with me right now. Anyway, see you in class. Bye.
Who do you play when your kid is up? Rat, pampered and spoiled like a Siamese cat. Blaming the kids is a lie and a shame. You know exactly who's to blame. The mother and the father.